everybody, and welcome to TypeScript Tuesdays, brought to you by Virtual Coffee, aka virtualcoffee.io. What is Virtual Coffee? For anyone who may be joining us who's already not part of our wonderful community, we are a tech-oriented community who's been around since March 2020 that tries to make meaningful opportunities for learning, leadership, and growth at all levels. We have a variety of wonderful activities. If you want to learn more about us, check out virtualcoffee.io. I am one of the maintainers of Virtual Coffee, Kirk. I'm normally here with my co-host, or should I say I'm normally co-host, to another wonderful maintainer and member and friend, Dan Ott. But Dan cannot make it today, so I'm doing kind of a solo stream. And today we will be doing something that I've been wanting to kind of touch on the channel for a while now, which is some TDD, not the TDD you're thinking of, TDD in terms of type-driven development with TypeScript. This is a topic near and dear to my heart. I'm a big fan of sort of what that means and its tenets, and I kind of wanted to share that with whoever's joining us today or whoever's going to look at this later. How we're going to do it, I was thinking, let's try something fun, something interesting, or something that I've been working on, which is making a sort of like minimal implementation of Connect 4 using TypeScript, some JavaScript generators. So if you're interested in learning more about those, this might be a good stream for that too. And yeah, just kind of talking about the mechanics of a few things: types, TypeScript, a little bit of like game design and game logic, but really sort of like digging into leveraging types for joy, for benefits. Usually on this channel, especially as you've seen us working through the virtualcoffee.io website, we have spent a lot of time dealing with brownfield projects, basically, projects that already had existing JavaScript and they're converting to TypeScript. And we've seen sort of like the pain points of that, the difficulties of that. But in this case, I wanted to take a look at something where it's not sort of like existing JavaScript when you're adding types. Dan and I have talked about this before, but I do think there's a slight difference between adding types to an existing code base and starting some new code with the types in mind. A lot of the benefits, a lot of the joys, I think, from using statically typed languages, compiled languages, type-driven languages, languages with expressive type systems like TypeScript happens when you get to start with the types first. So that's what we're going to try and jump into. So what I'm going to attempt to do is just to sort of make this as accessible as possible, as much as like live coding can be. We're going to see if we can use sort of like online environment just for quick prototyping. And I have always been partial to Code Sandbox. So if possible, we'll try and use a little Code Sandbox instance to kind of get this going. It's gonna, I'm thinking it's gonna be a React app. But honestly, the React part is not going to be the critical part of this. It's mainly going to be about like TypeScript and type-driven development. I just need something to sort of like render what's going on, and so we're going to use a React app. But if you're looking for like, oh, this is where I learn React, I don't know, this is necessarily going to be the stream for that. Although, if while we're doing it, anyone has any questions, we can like jump into that. That's not a problem. Cool. Okay, so let's see if I can share my screen. Let's see if I can find my screen. And then if I find it, let's see if I can share it. Where are we? Technology is hard. But I think we can get there. There we go. gotta find a way to do this without showing all the weird tabs that I have open. Because I tend to not close my tabs for years. Um, there we go. I think that's visible and folks can see it. Just a quick check to make sure that it's looking good. Let me know if I need to sort of like make it any bigger or smaller for those watching. We can always zoom in or out. But yeah, we'll start here. So this is like the bare bones of a TS-based React app. This is all it's rendering at the moment, which is really nothing, right? We've got this default thing, default app here. We're passing it into sort of like React's create root function, and it's doing all the hard work for us. And we've just got a basic div. But yeah, we're not here to talk about React. We're here to talk about Connect 4 and like games and TypeScript. So let's just like do that. I've spent a lot of time making games in the browser, especially board games, especially 2D games, because I don't have the talent to make 3D games and I don't want to do all that math. But I've done them for quite a while. And there are certain mechanics and elements that are sort of like common to all games. But if we step back for a second, we can see that like it's not the fact that they're games. It's not only the fact that they're games. It's the fact that they are sort of like pieces of domain logic and interfaces, right? Like every meaningful game has a way for players to interact with the game and a way to sort of like update players on the status of the game. And when you look at it in that context, right, like a way to check in with a thing and a way to get like messages back from a thing, then it starts to sound like all the things that we normally think about for software design, right? We can call it an interface, we can call it an API, we can call it a function, which in this case will be very relevant. We can call it like an object, but that's all like games really are, right? There is some thing that represents what the game is. There is some way of sending messages into that thing, and there is some way of receiving feedback. You know, the details of that, turns, changes, armies, hit points, implementation, right? But the core concept like remains the same, and that's sort of I don't know. There's some like general sense of all of life is just like interfaces, but we don't. It's Tuesday. It's also like the 30th year. It's too early for that. Who is in the chat? Ayu's in the chat. Hey Ayu, welcome. I think you might have come in after my little intro. I'm doing just some type-driven development today, talking about TypeScript, using it to make like a simple game. Using it to make Connect 4, actually. We're going to make Connect 4 using TypeScript and type-driven development. And I'm going to sort of like let you all be a captive audience for my thoughts on TDD, game design, interface design, all that fun stuff. So that's where we're at today. So we're talking about, maybe I'll start like typing as I talk. Maybe I'll keep things in context for people coming in. So this is going to be all about Connect 4. This is going to be about type-driven development. This is going to be about, nope, that's the thing, API design. That is what we are doing here today. So, yeah, so I was saying like, any game is just like players sending messages into the game and then the game sending like feedback out of the game. And that's how we keep track of every game ever made. That's just how like interaction works. So the question is, whenever I start a project like this, like, oh, okay, I'm going to make a game or I'm going to make really anything. It's like, what's sort of like the core? What is the game? What is Connect 4? Not how does it work necessarily. It's sort of like, what is it as sort of like a thing? Meaningful software development generally involves taking some external real world concept, right? And we translate that into data structures and like operations that manipulate those data structures, right? That's what like all code is doing. Like it's pretending to be, if you go to Amazon and you put something in a cart, there's like code that's designed to represent what it means to like select an item and place it in a cart. It's not an actual item. It's not an actual cart, right? It's just like a mapping to that. And generally, when we want to do good or efficient design for our code, the better that mapping of like what things are and what we need to what we've represented, the better things tend to go. It's sort of like easier to test and easier to expand and easier to explain. And if you're working with software and you find it just like hard, it's always difficult to change and manipulate, usually that tells me that there is some resistance between like what our thing actually is in real life and how we've represented it in our code. So we're going to try and like nail that today as best as we can. So Connect 4. For those who might be unfamiliar, Connect 4 is a game, fun game, all ages, with a very simple concept, right? You have a grid, and it involves 2 players. Each player takes a turn. They can drop a coin or some sort of item in the grid. Usually in real Connect 4, these are distinguished by colors. So like one player gets the red, one player gets the black or the blue, or you can do symbols on the coins, anything like that. But some way to distinguish, like there's one player and there's another player, they take turns. The first player who can line up 4 of their token in a row, whether that be vertical, horizontal, or diagonal, wins. Typical Connect 4 board, we're going to say, has 7 columns and 6 rows. So if neither player manages to do that and all the rows fill up, then the game's a draw. The game is officially a tie. I like to think of Connect 4 as sort of like the big brother of tic-tac-toe, which is why we're not doing tic-tac-toe, because lots of people do tic-tac-toe. I don't really want to get into tic-tac-toe, but they're very similar. A lot of the concepts like work for both of them. So it's still like a approachable enough space. Cool. So we know what Connect 4 is. The question is like, how am I going to represent that in my data structures? And that's maybe like the first thing I think of when I think of like type-driven development versus non-type-driven development, or when I'm working with TypeScript versus JavaScript. A lot of times when I'm working with JavaScript, I'm immediately getting into functions. I just start writing functions. Oh, I need a function to do this, I need a function to do that. I need to like do a bunch of things. With TypeScript, I tend to want to take a step back and go like, okay, but what are the things? What are the data structures that are relevant to me? Let's do that first. Let's say what those are, and then we can see like the functions to kind of put them together. Let's get into it. The first thing I think of, and we'll do like a little naive implementation of these things, and then we'll kind of like bring it back, is, oh, I'm playing Connect 4. This is easy, right? Like I need a player, right? I need some kind of player type. I'm going to say like, oh, that's a string. And then what do I need? Like I need a turn, right? Because there are different turns, and that's a string too, or something like that. And then I might say like, oh, well, I need some sort of like board or grid. And my board is like, it can be like an array of strings, right? Like a 2D array of strings or something like that. This, there we go. Maybe I need a capital. Is it a capital? Oh, wait, no, I'm being silly. Something like that, right? This could be sort of our naive implementation. Connect 4, you need a player, you need a turn, and you need a radar skip. I see the Harper in the chat. I don't know who that is. I don't know which handle that is, but hello, welcome. Yeah, you're right. E2, we're going to use an array to represent the grid. And then you're also asking, could we make the turn a bool? That is an excellent observation. Oh, it's Andrew. Hey, Andrew. Great to see you. Okay, that's awesome. Okay, so we got Ayu and Andrew. That's lovely. So can we make the turn a bool? We absolutely can. And that is a good observation, right? Because, and this is sort of what I want to get into here. the first time you approach types in TypeScript, it can be sort of like a mystifying concept, or at least a very abstract concept. Like, I pick this thing that represents like what something is. Um, the way I like to think of types simply is sets of values, right? So when I say type player or string, I'm saying player could be something in the set of all the strings that JavaScript can make. And a turn can be something in the set of all strings that JavaScript can make. And a board is an array of something in the set of all strings that JavaScript can make. But yeah, when you can do that, let's think back to like just Connect 4. Connect 4, it doesn't really make sense for me to say like a turn is any one of those things. There's only two turns, right? And there's only two players. So why should it be a string? So you're right, Andrew says in the chat, we could just make this a Boolean, right? Like, so, instead of calling turn, you could even call it just like, if you want to like give the type a more meaningful name, it could be like, is player one's turn, right? A type representing like is player one's turn. And it's a Boolean, right? And it's like, oh, well, if player one's turn is true, then it's player one's turn. And if player one's turn is false, then it's not player one's turn, right? So that could work out really well, and that'd be really cool. I don't know if you notice, like, there's another thing here that's sort of like a big, not necessarily like the biggest revelation, but there is sort of like a logical conclusion now that we've established that turns are just Booleans representing which player is playing. It's sort of like, do we need a separate player at all? Like in the domain, and I'm going to use the word domain to represent like the thing we're actually trying to figure out. In the domain of Connect 4, is there really a difference between a player and their turn? The answer is maybe. In a mature system, in a mature piece of software, a player might carry a bunch of info, right? Like, say you're doing like a real game, there might be sort of like an IP address associated with a player. There might be, like browser dimensions associated with player. There might be a bunch of things, right? But those are all implementations. They have nothing to do with Connect 4. They have to do with how you're rendering Connect 4. For the purpose of Connect 4, the player and the turn are exactly the same. So the first thing, I don't even need this like data type at all. It's sort of like, what is player one is just their turn. If I know the turn, I know the player. If I know the player, I know the turn. Oh, what piece is going in the board? Well, whose turn is it? Right? Who won the game? Well, whose turn is it? Right? So immediately there, as we start walking through the types, we see this opportunity to just like reduce, right? We can like simplify our data structures associated. We can make them like really, really like minimal and clean. And that feels very good, right? That feels great, actually. Because there's less types to play around with. It also means there's going to end up being less code to play around with. It means the code has to work. These things are simpler, right? When we have like 3 different pieces of info, that's like 3 things to track. Now we have 2 things to track, but they mean exactly the same thing. We haven't lost any power. We haven't lost any complexity. We've just like gained more efficiency. So that's sort of like the next thing I would do here, which would be like, oh yeah, there's no real difference between players and turns. It might as well just do that. There's one other thing I might do here, actually, which has less to do with the amount of like data and information we're carrying for the software, but has a lot to do with like us as the programmer, us as the person reading the code and rationalizing about the code. So we did a thing here where we said player turn is a bool. And that's fine. That works. That carries the information we want. But I'm going to take a step ahead here and say, problem or the potential problem of doing this as a Boolean, right? Making player turn or turn a Boolean is that now, wherever we interact with this in the code, we're going to be passing around these true and false values. And I'm going to say this premise, and you may not agree with me, or you may think it's not as relevant, but I think like it might present pain points sometimes when we're trying to change and work with this code, and we just see this bool floating around. And we have to remember, what does this Boolean mean? What does true mean? True, the two values in Boolean, true and false, are very, very general, and they don't really have any context for what's going on here. They're just true and false. And we can make it work, and we could like parse through it, but I'm going to say that I'm going to make a change to this. I'm going to change this type back to player, and I'm going to change this Boolean to just be the two strings, 1 and 2. So a player, so we started with just saying player is all strings. And then we sort of quickly decided, well, that's too much, right? Like that's overextending ourselves. We're going to end up in trouble. Allowing player to be all strings just introduces bugs to your system, because now there's no way to know if like values passed are correct. People could pass in anything. It's a valid player. TypeScript will never warn you. So then we said, well, let's make it a Boolean, right? It's only 2 values, 1 or 2. We've narrowed down our set to just 2 things, and that's much safer. But we don't really get much information from that. Now we're saying, let's keep it at the 2 values. That makes sense. But let's just like give them meaningful names. In fact, I'm going to change this to player 1 and player 2. I'm going to call player this. And this is going to be the 2 things I pass around my application. So every time I interact with player, I either have to say player 1 or player 2. TypeScript will ensure that I only say player 1 and player 2. But the nice thing is, wherever I see these, I know exactly what they represent, literally, right? So this has a bunch of advantages, and we've talked about like we've narrowed down the space. It's easier to test. It's easier to catch bugs. TypeScript will now do the work of making sure that we've passed in the right parameters. But a big thing that you do when you do stuff like this is you've moved information about the domain, right? We've moved information about connect for from our heads or from functions to types. Types that live at the top of the file, types that have a bunch of meaningful information. And that sort of like aspect is really good for refactoring. It's really good for returning to code bases. It's really good for documentation, right? Just put the relevant information, right? The meaningful information, just it's in your types now. It's not just like scattered about. So this is what I'm going to do. And then sort of similarly, what we said, what was this board? We said it was like, oh, it's just a board of strings. And we could have probably done like string player 1, string player 2, and if there's nothing, like an empty string. But again, that's not really true. A board can't just be a bunch of strings. A board is like, it's like either there's a player token, a turn token in there, or there's nothing in there. So let's just say that, right? So, well, how would we say that? How would I say that? Well, I would say, what's a board? A board is, it is a 2D array, but I feel like the things that are going to be in a board is either player or nothing, right? That's what a board is. That's what a connect for board is. If you look at any element in the board, you're either going to see something representing the player that played in that board, or you're not going to see anything, right? So let's just say that. And once again, we've migrated information from our heads about what we're working on to the type system. Now TypeScript will remember, or what this is supposed to be for me. And when I come back to this code 6 months from now, I'm like, what was this all about? I'm like, oh, well, there's a player and it's these 2 things. And oh, there's a board. And it's like, okay, that makes sense. We're getting there. We're getting better. So that feels way more relevant and way more like meaningful than what we were doing before, right? That's the types are now matching what we want, not what's there. We decide what we want, and then we make that into types, and then those types make sure that that's the only things that can be there. So I feel like I just took 20 minutes to write 2 lines of code, but I feel like it was worth exploring the 2 lines of code and like just to recap what were the important things there. Whenever you're working on a problem, it's worth spending time on like what is this thing I'm working on, and try and see if you can represent it in the types. Um, when possible, try and avoid, or I should say, be very careful about the basic JavaScript types. When I say the basic JavaScript types, I mean strings, numbers, booleans, general, generic arrays, like all these things have a place and a purpose, but don't just think of them as the end to your functions and your data. Think of them as like little composable units that you can take to build things that are more meaningful, things that are actually relevant to you. The classic example I always use is ages. Whenever I have to represent an age for some kind of system, a login system, any sort of record, very often you'll see people make age be a number. That's a funny song reference, like const age will be 0. It's like, oh, what's age? And be like, oh, age is a number. And I'm like, age is not just a number, in the sense that if you think of every possible number in the JavaScript ecosystem, and you think of all the numbers that could be a valid age of a human, almost no numbers are ages. Most of them are not, right? They involve it, like they're a subset of them, but they're not the same. So usually I end up making a type and I call it age, and I would have like some way of representing. Usually I do it with like a little record, and I do something like that. I do something and I make something like to age, right? I make a little function that takes a number, and then like returns age. And then in this function, I would put all the logic I need to make sure that like it's actually a real age. But in the rest of my code, I'm never passing around numbers around. I'm passing around ages because I know that once I get an age, it's exactly what I want, right? And then when I'm working with the code base later and I see this special thing, age, it reminds me like, oh, this is not just a number. There's something more going on here. And when I'm using functions that have it, when I see age instead of number, that's when like, oh, this is a function that works with age. It's not just a function that takes any number. So at every step of this, the type is like giving us safety, right? It's like giving us suggestions, because here, whenever I try and work with a player, if I say a thing coming as a player, TypeScript will tell me in like a VS Code ecosystem, oh, this is going to be player 1 and player 2. But it's also giving me information about like, what am I actually doing, right? Now that it's a type and I see that type around everywhere, it's like, oh, this is the actual thing that this is. It's not just some abstract value. It's a thing that means a thing in real life that I care about. So okay, that's enough of that. We really need to like do more stuff. But I really want to drive home like, what is the point of this versus just strings and bools, right? Safety, less likely to make a mistake. Simplicity, you've narrowed down the amount of values into just the things that you really want it to be. And also like documentation and meaning. You've lifted the context, right, from just your head to the code base. And all those things combined can really make things go a lot smoother. Okay, so let's keep going. We're still making Connect 4. Cool. The next thing I tend to think of with games, especially any game that has an ending, is like, what are the states of the game? And state is a word I feel like is becoming like more and more into the forefront recently, especially if you're working in systems like React. React talks about state a lot. There's codes like QState, right? State is just anything that changes in the course of something going on, right? Like if it changes as time passes, if it changes as the application runs, then it's part of your state. You know, if it never changes, then it's not part of your state. Um, Games are state-based systems. Games are always updating, right? Otherwise, the game would never end or the game would never progress. Either way, it's not a valid game. So I usually type to think of like, what are the different states of the game? So again, let's look at sort of like the normal implementation of this, and let's look at like what I think would be a more efficient or a more meaningful implementation of this. So usually people will do something like type and they'll do game state and they'll be like, oh, well, the game's got like players, right? And we'd be like, uh, players is like a list of players. Um, and then the game's got like the turn, and the turn is like, well, what's one of the players' turns? And then the game's got like a game board, and that's gonna be like the board, you know, and then what's going on, right? Like the game, like maybe like maybe the game is drawn, maybe the game ended in a draw, like I'll draw, and that's I don't know, what will draw be? Like a boolean, sure, a boolean. And then finally, we might be like, the game has like a winner, right? And then that's going to be like a player or no. Um, this is usually the type of thing. Let's see play it. I'm gonna do a quick refactor just to not a refactor, a quick format. See if that makes this. There we go. Just a little nicer. So this is a typical thing that I see. People like, oh, there's players. There's the turn. The turn is one of the players. The game board. Um, is the game a draw? And then like, is there a winner? Right? And this is a state that people keep checking as the application runs. Right? Like, whose turn is it? What's the board look like? Is the game drawn? Is the game winner? Et cetera, et cetera. And this is fine. But there's a couple things about this that we can probably change and improve. And it gets back to what we said earlier about data and types just being sets of possible values. There's a very big relevant paradigm you hear a lot, especially in the functional programming community, which is make impossible states impossible, right? Whenever you're working with types and data structures, try and make your data structures in a way where things can never end up in a place that doesn't make sense. Now, looking at this, it might not be obvious why that's relevant here, but what we can do here, right? I can make a value game state, and I can say that it's a game state. And in that value, I can do something like this. Players. I say players. I'm going to do this. I don't know if you saw the IntelliSense had us there, right? When we said, oh, this is going to be, because it knows GameState's got to have a list of players. When we did that, it tells us, which is great, which we wouldn't have gotten if there was a string. So, all right, great. Just quick point out. Turn's got to be a player. So, this time let's do a player two. Doesn't matter. Game board. And we don't really have any rules for game board right now. So I don't know, we can just do something like this. And I think that'll pass muster. I think I might be missing commas here. Something like that. I never remember how syntax works. So there's the game of draw at any point in time. I'm like, oh no, it's not a draw, it's false. It's not a draw. And then finally, or actually, let's say that it's true. Let's say it is a draw. Game's a draw. And finally, I'm going to say the winner equals player one. We're going to do something like that. And it's yelling at me. Why is it yelling at me? What have I done? Unexpected token. What did I do? What have I done? Oh yeah, this is I've been bouncing around between like 3 or 4 languages recently, and I can't remember the syntax for any of them. Don't be like me, kids. Just do a thing. Okay, so we're here. We've got this. We've got this game state. And if you look at it, there's a couple weird things here, right? Like, first of all, players, we know the game of Connect 4 always has 2 players, but here it only has 1, right? Because it said players is a list of players, and the list can contain anything. We could have even done none, right? And that's perfectly valid. According to this type, according to this data structure, this is a perfectly valid game state. But that's not true, right? That's impossible. The game cannot also both be drawn and have a winner. That doesn't make any sense, right? So the point I'm trying to make here is that, like, again, when you're making your data structures, when you're making your state, you can really get yourself into problems if you just like keep stacking things. Every time you introduce a new type, a new field, you're saying, well, it could be everything, but also at times like all of these things, but also all of these things, but also all of these things. And every time we use like the default things where we just stick to like things like lists, strings, numbers, we are saying all of these values are okay. And once we do that, TypeScript cannot help us. TypeScript cannot tell you that you spelled player 1 or player 2 incorrectly if you say player is a string. TypeScript cannot help you if you forget to put in one of the active players if you say it's a list. When you separate things like draw and winner, what you're saying here is like, these are 2 independent things. So TypeScript can't tell you, hey, you can't be in this while this is happening, right? So where do we do that typically? We do that in functions, we do that in like validation logic, we do that in tests, and that's good and fine. And you should have validation logic, you should have tests. But the point I'm trying to make is like, when possible, what if we don't do that? What if we just like move that information of like what actually makes sense to the types? So let's try and write this again. What I would do here is, if I was working on this, is I would realize like there's actually 2 different things going on. There is what the game looks like when it's active and what the game looks like when it's complete. So I'm going to split this like game state. I'm going to make a type. I'm going to active state. And I'm going to say that active state just has 2 things. It's got a turn, and that's a player, and it's got a game board, and that's a board. And that's when the game is active. All I need to know to run the game is, what's the game board look like? Whose turn is it? That's it, right? There's no concept of winners because it can't be a winner because the game's still going on, right? Can't be a draw, the game's still going on, right? There's just a turn and a board. Now, what does the game look like when the game is over? So we're going to call that completed state. I'm going to hate that spelling afterwards. There we go. When it's completed, I'm going to say there's winner, which is player null. And there's still a game board because I probably still want the board when the game's done. But no, there's no turn here, right? Because when the game's done, there shouldn't be a turn. It shouldn't be possible to think about turns. Similarly, draw is kind of a redundant concept, right? If there's a winner, then that's a player. If there's a draw, there's no winner. So instead of having draw and winner be separate things that I have to track, well, let's just make it just winner, right? Winner's nullable. If there's a value there, then that person won. If there's no value there, then it's a draw, right? So we've taken this sort of structure here and we've turned it into these 2 structures. And then I might fuse it and say like type, my final type game state. is now active state or completed. And that's going to be my final thing here. We can get rid of these. And this is a space, right? I sort of like, right? Because now we like these are we've separated like two funnily separate things, but like mainly we've prevented a bunch of like errors from happening, a bunch of logical issues, a bunch of things. I cannot mess with turns when the game is done. I can't try and get the winner. Like it's not even that there's no like weird default values that don't make any sense that we need to set, like it's just clean break, clean separation. And again, when I'm reading this code, there's a player, these are the players, cool. The board has players or it doesn't, cool. When the game is active, there's a turn on a board. When the game's done, there's maybe a winner in a board. That reads like the space that I'm in, the domain that I'm in. I'm not just reading a bunch of like strings and numbers and lists, No, we got rid of the player list because we don't need it, right? Turns can only be turns. Turns can only be players. There's only two players. So it's sort of like that concept is already like baked in. Don't have to re-represent it. So just less code to write. This I'm pretty happy with. The last couple types I want to make here are just going to be types about sort of like the board. Now we really haven't defined sort of Connect 4 too much, and here we're sort of going to get into game logic. So we chose to represent board here as this sort of like array of arrays. That's fine. Times says reset. Reset is an interesting concept, and we'll kind of get into that later. Reset is not something that we yet need to represent in our domain. Like, no, it's like we've written no JavaScript here. We haven't even written a single function. We're just in types, Yeah, the last thing sort of like in that vein I want to talk about is here we're saying board is a two-dimensional array, and that's fine. There are very often times in games where you don't want, even though the game is played for people as a board, the actual representation in your code might be better as like just a single array or a stream or whatever. Here, I think board is fine. The two things I kind of want to make really sort of like clear is I'm going to make this thing called a position. Because if it's going to be a grid, we sort of need to keep track of that. I'm going to call positions this tuple. If you haven't heard that concept before of a tuple, JavaScript doesn't really talk about them. A tuple is just a fixed size group of values. You can think of it like that. So when we say a position is number, it can only it's just the two things. You can't extend this. You can't shrink this. It's not a list. It's just number and a number. So I'm going to make position to represent where we are in the array. And I'm going to make this thing called combo. And you'll see why that's relevant later. But combo is going to be for positions, right? And combo represents basically like what you need to win. To win, you need a combo. And combos for positions. So I'm just going to take our time right now and just like bake that into the types. Let's just keep it here. So it's up here in the code and not in our brains. It's also going to make like a lot of our functions a lot cleaner, and TypeScript will complain less because we've told it what to expect. Because TypeScript is really good at like, hey, the thing you're doing might be wrong. If we just passed in like a list, like, what if this list is empty? What if this thing you want isn't here? So if we tell it, no, it's always going to be a bunch of positions, TypeScript goes, oh, okay, then that's fine. So this is what we're doing here. Yes, Andrew, exactly. So where they are next to each other, right? Like it's always going to be sort of like an X and Y value. If we think of Connect 4 as a bunch of columns and a bunch of rows, So these positions represent each one of those, and then a combo represents 4 of those. We're going to do that. That's going to hopefully work out. Okay. And at this point, let's try and start writing some code. So first, let's see if we can make a game board. I'm going to start with 7 columns and 4 rows, I think. Using this convention, I don't know, for anyone who's watching this hasn't seen this before, if you're using constant on values, there's been a convention for a long time in software to just capitalize the entire things. So it's like immediately obvious, like this is a constant, and nothing changes this. Less relevant nowadays of things like IDEs and helpers and all these things, but it still feels useful. I don't know. Software is a weird mix of like things that are just meaningful for you, the writer, reader, and then things that are actually helpful for the compiler. And everyone sort of picks where they align there. So we're going to do that. Let's try and make our initial board. Just a fair warning for folks. I like sort of more functional style JavaScript. So I'm going to be using a lot of like pipes and a lot of arrow functions. If anything seems confusing you're watching, just let me know and I can kind of walk through what's going on. But to make the board, we're going to sort of use the array from function. So we're going to make an array from, and then what we want to make it from is the length. Let's see, how do we do that? Let's do the length. And then we're going to do this because we don't really care about that. And then we're going to do another from. This one is going to rows and something like that. If I've got my syntax correctly, which I may have not. Yeah. Hold on as I try and figure out what I said here that is strange. There's also, the last time I was testing this, I was using TS version, one of the latest versions. I wonder if it still works. It's the latest one. So the lib 2015. Let's try changing this to TS. Hope it doesn't hate that. Let's see. Andrew says Connect 4 7.6 if you're wondering. Yeah, okay, so we should be good. Thank you for that. Because I was never sure. Need to learn more object-oriented programming. Yeah, no, I totally understand that. And to be honest, you can get very far in JavaScript without ever having to write like a single line of functional code. But you know, it's good to know just a little bit. Okay, I think I've gotten too fancy with this. Let's see if we can make this a little simpler. Array constructor, interterm iterable. How did we do this the last time? If this is getting to be a pain, I might actually just skip it. Basically, like these like take a function that returns a value and then like sort of like iterate through that value. let's do something like this. Let's do something like this. Maybe not. Maybe that from rows, but it's okay. No overload matches this needed iterable and array-like something. Turn like iterable. No. Need an array-like. Okay, I'm gonna briefly leave this alone for a bit, or let's see if we can be like more. Let's do some research. Let's do some improvement and remember how array.from is in JavaScript. Oh, I don't remember what I was saying now. I was trying to cheat. What I was trying to do, this looks for a length property on an object. So what we're trying to say is like, hey, oh, okay, no, it's fine. I don't know why. I'm not gonna push it. Okay, cool. Guess that worked. Let's not think about why it's something we can. Good. Okay, so this is what we're trying to do. We're just making an initial board. We're basically saying make an array from the 6 columns and the columns and the rows. So 7 columns, 6 rows. Just like use those and like generate an array from each of those. And we're going to fill them all initially with none, null, because they have no values in it, which matches what we said. Like the board can be players or nulls. So this is fine. If we try to make this, then it would complain. Hey, that's not what a board is. A board can't have random characters in it. It can only have a player or null. So that's working as intended. I'm going to leave that. I'm going to not worry about why it didn't work the first time. Let's then set up our initial state then, right? And we know our initial state is going to be an active state. And I'm going to say, I start with a term, and it already knows, turns out to be a player 1, player 2, so I start with player 1. And we're going to need a game board, and that's going to be our initial board. And we're going to call that the initial state of our game. We started player 1, and we started with an empty board, and that looks right and correct. We can even take it one step further. We could say like game state is initial state, active state, completed state, and we could like, well, maybe initial state only has an array of nulls, right? So there can't even be a player in the initial state. And like there's the thing that comes with time and practice is like how much you want to typify stuff, how specific you want to be. There's a certain point where it becomes like overkill, or it becomes like super painful to work with. If you wanted to be super sure, you could do something like that, right? We could take the fact that a board, we know a board never has a player in it, and like put that in a type, and not just in like this constant and like hoping we did this properly. So that's just something to think about. But we'll leave it there. So what time are we at? We're at 12:56. So this might be a 2-part thing, but I want to at least kind of walk through what we're going to do as we move on here, because I think it's like we'll just do like a preview of like what's going to happen next. So I'm going to try and do this, or we're going to try and do this entire using JavaScript generators. For those of you who don't know what generators are, it's a lot, but a generator is just something that can like be iterated through, or as an iterable or an iterator. right? Anything that works with like a for of loop is um, is an iterable, and generators let you make those like really really easily. So what we're going to do is we're going to put the entire logic for this game in just a little generator function, and the idea is to make everything we need to play a game of Connect Four in under 100 lines of code. So where are we up to right now? We are at line 26 in comments. And yeah, we're going to walk through like how do we sort of like seed the initial state of the game? How do we work through the logic of updating the game? How do we get to the final value? How do like players interact with it and like making a small API from the generator? That's probably going to be next week if Dan lets me. But for now, I guess I just want to do like a quick recap on what today was, which I think was like sort of the core thing, which is like the idea of turning your domain into types. Like we did Connect 4, but you can do this for any game, like even the most complex game, like Doom or Hades or Need for Speed or Grand Theft Auto. Like at the end of the day, all games are some piece of state made of like elements that change and then interfaces to like send messages to change those elements, and then interfaces to get feedback of the game for people to like play and update the game. Every game has a concept of like how it starts, what's happening while it's running, and then like what it looks like when it's complete. And you can break those down into phases. If there's more phases, you can get like as deep as you want. But at any point in time, you have the ability to represent those in a type system. You always have the option to stick super basic strings, numbers, arrays, but you are doing yourself a disadvantage and you are making it harder for yourself if you have access to a type system like TypeScript, but you're keeping everything as just the basic JavaScript types. You end up having to do more testing, more validation logic, and just like keeping more stuff in your brain versus getting it down here and just letting the compiler sort of like help you. You still got to think about the game, but having a compiler's help, having TypeScript's help to make sure that like things are right is really powerful. And like this, coming back to this is a huge advantage to me versus just coming back to like numbers and functions, you know, seeing what things are like is just the biggest help to me later on when I'm actually going to use these things. So yeah, I think like next week, hopefully Dan will be around and I will show how we're actually going to use these to use these basic types to like build out something more complex, build out something really fun, really like functional, which is also one of the big parts of this. Like there's going to be no sort of like explicit mutation here. It's all, almost all consts and functions. But yeah, just having like a nice little testable, achievable, expandable little piece of code that kind of does something cool. But yeah, with that, it's about one now. So I'm gonna stop for here. To all the folks who came out to the chat to, hey, have a good day. Thank you for checking it out. If you found this sort of online or on YouTube and you want to know more, again, just check out virtualcoffee.io, where we have a list of like everything we've got going on. A lot of amazing things happening in this community, a lot of amazing people. But yeah, thank you for coming out, and I hope you all have a great day. I will see you later.